Hey guys, this is Mr. Gagnon again, and I'm going to go over with you guys number 58 on the homework. So what this is it's your questions that you had in relationship were number 55 to 57. So in 58 it says that a horizontal force of 100 newtons is applied to the object. But let's see what object we're looking at. Okay. All right, so a stationary 15 kilogram object is located on a table near the surface of the Earth. The coefficient of static friction is 0.4. The coefficient of kinetic friction is 0.25. Okay, so that's what they give us. And in number 58, it says a horizontal force of 100 newtons that's that, is applied to the object. Okay, and it asks you to do three things. It says draw a free body diagram, determine the force of friction, and determine the acceleration of the object. Okay, so we've got a lot of things going on here. So free body diagrams, as you know, okay, are just dots with arrows. So what I've got, and you can start with a regular picture too. I mean, this is like a semi-free body diagram. We can draw in all the forces in the picture as well. We know that this is mg, this is normal force, this is force of friction. So if we were to draw a free body diagram of that, it might look like this: 100, force of friction, mg, that's the weight, and then the normal force. Okay, we got to figure out what these are. So there's our free body diagram. That satisfies A. Okay, now it says determine the force of friction. Okay, now we know that the force of friction, we're assuming this is accelerating, but the force of friction is equal to the mu times the normal force. Well, they gave us a mass, so we can figure out what that is. That's 15 kilograms so the weight of the object is 147 newtons. Now we know it's not accelerating up or down, it's going side to side. We can safely say that the normal force is 147 newtons. Okay? Now, it asks us in part B, what's the force of friction? So let's see what we got. Force of friction equals mu sub k, which we found was which we know is 0.25. The normal force is 147 newtons. So force of friction we found out what it is. So this is pulling to the left at 36.8 newtons. Pulling to the left at 36.8, to the right at 100. Okay, so let's see what else we're looking at. Okay, this is part B. This is part A, and we're going to do part C now. It says find the acceleration of the object. What is the acceleration of the object? Okay, using Newton's second law, okay, we can go ahead and find the acceleration of the object. So we know that acceleration, and we've done this a few times, is net force over mass. Okay. Now net force is all the forces added up. So let's figure out what that is. Net force, well, these two cancel. These equal 0. The net force would be force applied plus the force of friction over mass. Force applied is 100 newtons. That's this one. Force of friction is negative 36.8 newtons. Mass is 15 kilograms. Okay, so I'm going to figure out what that acceleration is. Okay, here it is. Acceleration of our object is now, it's 4.2 meters per second squared. I think that satisfies number 58. So that's how you get the acceleration given, given our mu values. Okay, and also using Newton's second law. That's this one. Okay, thank you and have a good day.